Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here, and Assalamu alaikum to all my dear students. Today I will start the chapter number 15 of this countdown 8. So the topic of this chapter is basic operation on algebraic fractions. So we will start with this topic, okay? Yes. So basic operations on algebraic fractions. Before that, first we have to be clear about the topic of fraction. Okay? Fraction. What are the fractions? For this, you have already done about the rational number. Rational numbers. What are the rational numbers? A rational number is a number that can be expressed in the form of A by B, where A and B both belongs to integers, and the denominator number, this cannot be 0. Okay, so normally we can say many numbers that can be expressed like this one, 0, 2, -3, suppose, which are being given. I have taken the same example from your book. Like these all are the rational number. They all are expressed in the form of A over B, where here is 1, here is B is 1, here is 1. Okay, but when we are solving these numbers, okay, when we are solving these numbers, if they are giving a real number on solving, then still it's a rational number. Okay, if they are giving terminating and recurring number, then recurring decimal form, in the decimal form, then they are rational number. Okay, means still if they all are giving terminating decimal, if in decimal it's giving answer, terminating decimal or recurring decimal, then they are rational, otherwise irrational. So on this topic I have done a separate video with the complete detail about this topic. Then but today's our topic is about the fraction. Okay, when we are solving the rational number, sometimes it happens that we are solving like a number like this or a number like this. Usually it's looking like a rational number. Okay, but when we are solving it, it's giving answer 2 by 1. Okay, it's also giving answer 2 by 1. So it is in the fraction form, but it can be written as the whole number also. This is written expressed in the fraction form, but it is not considered as a fraction. It is considered as a whole number. Okay, it's considered as the whole number. So when the denominator B, denominator in this one, this B is not a multiple of A. Numerator A is not a multiple of B. So then it is still a fraction. Okay, means A is not equal to, means B is dividing by A is not giving a whole number answer. So still it's a in the fraction form. Okay, in algebraic expression, obviously you will get the algebraic expressions in the numerator and in the denominator also. So we will go for the simplification of algebraic expressions. Okay, so before doing the simplification of algebraic expression, let me revise a few basic algebraic identities. Okay, before the simplification, in the algebraic identities also, today I will express the algebraic identities with a different way. Okay, what is my way? Usually I explain to my students also, in the identities, just keep in mind there is a factor form of the identity, factor form, and then there is an expanded form of the identity, expanded form, like a plus b whole square. A plus b whole square, it's a factor form, and it's expanded as a square plus 2ab plus b square. If the any identity written like this, it means it will be converted into the factor form like this. Similarly, a minus b whole square, it is a factor form, and its expanded form is a square minus 2ab plus b square. Okay, a square minus b square, this is expanded form, and it will be converted in factor form as a plus b and a minus b. Okay, going on to the next basic identity, a plus b whole cube. Its expanded form is a cube plus 3a square b plus 3ab square plus b cube. A minus b whole cube, it's equals to a cube minus 3a square b plus 3ab square minus b cube. A cube minus b cube or a cube plus b cube, that is extended form. A cube plus b cube, and its factor form is a plus b, a square minus ab plus b square. Okay. A cube minus b cube, its factor form is a minus b, a square plus ab plus b square. Okay. So I think if you know all these identities, and if you know what is the factor form of the identity, what is the expanded form, then it is easy to go for the simplification in algebraic expressions. Okay. So let's go to our question now. For the simplification, this is our first question. Okay. In this one, we have to factorize numerator separately and denominator separately. So this identity will be written in factor form, and this identity also will be written in factor form. For this, that we have to keep this in mind, that this is looking as like this one and its factor form is like this. So I will write it over here in shortly. What is the factor form of this identity? A plus b and a minus b. And denominator is expressed in factor form as like this. Use this formula, a minus b, a square plus ab plus b square. When you factorize numerator and the denominator, now you will see, for reducing to the lowest term, that is there any factor common in numerator and denominator. So this complete factor is common in numerator and denominator. I want to use the pencil for the cancellation. Yes, this one. Complete factor can be cancelled by the complete factor, and the remaining is a plus b over a square plus ab plus b square. This is left. So this question is solved just in a few steps. Next, check please question number 2, that is x square minus y square whole square divided by x plus y whole square. First, we will factorize the identities inside. This identity again looking like the same, this identity. So it will be converted into its factor form, x square minus y square. Only the first term is a, second term is b. So it will be open same like this one. Okay. X plus y, first term plus second term, first term minus second term. This external whole square will be placed as it is. Okay. Then x plus y whole square mean this complete factor can be written 2 times. Like we have done the exponential topic also already, in which I told you that 2 square is equals to 2 multiply 2. 3 square equal to 3 multiply 3. 4 power 3 equals to 4 times 4 times 4. Means the number will be written 3 times according to the power. If we have 2 power 5, it means 2 will be written, or 2 multiply to itself 5 times. Like this is the meaning of this. Okay. Now what we do, we have 2 factors and square on the both. So first term square, x plus y whole square, and x minus y whole square. By mistake it's written like this. It's okay. X plus y and x plus y. Now x plus y means 2 times x plus y. Okay. So 1 time its power cancel, 1 left. 1 time this full factor cancel. So what is the answer left? Answer left only x minus y whole square. So this is completely solved like this. Going to the question number 3, it's a plus 2b whole square divided by a cube minus 4a b square. So first upper one a whole factor but square. Square means the same base number will be written 2 time, means a plus 2 will be written 2 time. Then this one, a cube minus 4ab square. If no identity applied over here, then we will check maybe any simple factorization method can be there, like taking common. What can be taken common? A cube and a. First, if we take a common, what is left? From the first term, a left. From the second left term, 4b. A left, a taken common, a square left. 4b square left. Okay. Still we see first term's whole square minus. This can also be expressed in the whole square term. So we will express in the whole square term to factorize. So this is the whole square of a and this is the whole square of 2b. Now write one time with sum of terms and difference of term. Sum of term is a and 2b. A plus 2b and secondly a minus 2b. After completely factorizing the numerator and the denominator, we will see anything can be cancelled. Yes, this complete factor is common. So what is left? The remaining numerator factors are a plus 2b and denominator factors are a times a minus 2b. Okay, so this question is completed till here. First question completed till here, like this. Okay, you may write like up and down also, no problem in that. Question number 4. Question number 4 is a square minus 2a divided by 4a cube minus 8a square. Let me write up and down, no problem. So if you take a common from the first term, so a common, it left a minus 2. Simple simplification. If you take 4 common and a square common, maximum from the first term 4 common outside, no number left. A cube, you take a square common, a left, minus 4 2s are 8, a square already common, nothing left. Now after completely factorization, what is left? That first term common factor is completely cancelled and leftover term is a in the numerator, denominator 4a square. Still a and a square, 1a can be cancelled to a square, here left nothing, so 1 4a. It is solved like this. Question number 5. X cube minus y cube divided by x minus y whole square, x square plus xy plus y square. Okay. Open the identity. Exactly algebraic identity is there with the first term as x and second term as y. So open the identity. X cube minus y cube open as, like in this one, x cube minus y cube. So it will be open like this, where first term is a will be replaced by x and b will be replaced by y. So we will open like this. If you cannot keep the identities in the mind, so it's better to write down the identity somewhere and paste into your area where you were visiting the most, like the side of the bed table or in the cabinet or wherever you want. Okay, better, so that whenever you're looking that on that page again and again, so identities will stay in your mind for a long time. Okay, plus product of both term plus y square. I suggest to my students also. X minus y whole square, it means x minus y, and x minus y can be written exactly same 2 times. And then this is the last term as it is. Now cancellation. This factor exactly same this factor. This factor exactly same this factor. Leftover numerator is nothing, so 1. Leftover denominator is this term, x minus y. Thank you so much. I think question number 1 to 5 are completed over here. So next time I will do the next part, inshallah. Thank you so much. If you like my video, so please subscribe to my channel. Allah Hafiz.